What happens when you stretch a circle left and right, this distance, the x distance, becomes longer than it does taller. When you stretch it up and down, your y distance is longer than it is to the x's. So what you get here is both of our formulas are going to be centered at the origin today. We're not going to shift anything yet. What we get then are these two equations. They are very, very similar. You get x squared over a squared plus y squared over b squared equals 1. And the other one is x squared over b squared plus y squared over a squared equals 1. The difference here is you'll notice is, everybody see how the a squared switches? The reason that the a squared switches within the denominator is that the a squared is always greater than b squared. A squared value is always going to be greater than the b squared value. So if the larger of the two numbers is underneath the x squared term, it means it's stretched left and right. If the larger of the two numbers is underneath the y squared term, it means it's stretched up and down. It's that simplistic. It's that simplistic. One of the new things that you will find out is that we wind up with what are called vertices and covertices. Vertices will always be on the sides that they're stretched. It's the major axis. The major axis, if it's stretched left and right, would be the x-axis. Or yeah, excuse me. And then if it's stretched up and down, it's the y-axis. So the vertices for stretched left and right will be on the edges there. The covertices will be on the up and down. And then it's just reversed the other direction. So what we are able to do here is take any one of these equations that is written in this standard form, where they always equal 1, and you're able to get these bits of information. So let's see, we have vertex is always going to be at, since they're centered at 0, your vertex is always going to be at a comma 0, negative a comma 0. Your co-vertex, I'm using CB, is that okay? Mm-hmm. For if it's stretched, this is stretched left and right, this is stretched up and down. 0b and 0 negative b. And then your focus, well, we'll talk about how to find those points here, how to find the value of c. Remember, if the vertex is stretched left and right, your vertex is always opening up to the focus. So the focus is always, always, always going to share the same y value, I. It's always going to share that same y value. So even when we do shift it later, it's just going to be up and around.
You're actually teaching today? That's so mean.
Damn straight, yeah.
Because these kids, they can't be expected to learn on a half day. We should just watch YouTube all day, Mr. Murphy.
I know.
Oh my God, that'd be
That's why he's not doing it.
I'm just giving quizzes every day on half days from now. Can't take it anymore. Do your homework.
What's that? So again, what happens then, if you're switching things going up and down, all these values just flip-flop. And when we do an example here, you'll see how very, very easy it is to work with these. So the vertex, if it's stretched up and down, is now going to be at 0, a, 0, negative a. Your co-vertex, b, 0, and negative b, 0. And then your focus, since it's stretched up and down, shares the same x value. Okay. Again, the only weird thing about all of this is going to be how you figure out what the value of c is. Because that's the only thing that you're not going to see in the equation itself. So as generic equations, yeah, it would be a lot funnier if you were off your phone.
Sorry, I was talking to my sister.
I don't care. Just put it away. Thank you. Yeah. So the only thing you have to worry about here is how do you come up with the value of c, or that value of c squared is what we're going to find here. And it's found by doing the following one step. A squared minus b squared is c squared. And that's how we were able to figure out what c is, where your focus is going to be liable. They're just weird like that. So let's just go ahead and do a couple examples and call it a day. I have the equation 9x squared plus 16y squared equals 144. I'm going to graph this and list out all the important parts, which means I'm going to label where my vertex, co-vertex, and my focus is. Okay? So the generic forms of these equations always equal 1. So in this equation, what would you have to do? Divide everything by 144. Set one side equal to 1 now. All right, divide everything by 144. When you do that, you get x squared over 16 plus y squared over 9 is 1. All I'm doing is just putting the generic form by setting the side equal to 1. All right. Now, this is a tough question, Jake. I know it's early for math for you. What's bigger, 16 or 9?
16.
Very good. Since 16 is the larger of the two values and it's underneath the x squared, is this one stretched left and right or is it stretched up and down? Left and right. So when you do these things, just give yourself a little idea that it's stretched left and right. That way you don't screw it up later. All right? It's very easy just to do that, and then that way you remember that, okay, if it's stretched left and right, I gotta follow those rules. So when I'm stretched left and right, now all I have to do is just label it out. Well, a squared is 16, b squared is 9, c squared is going to equal a squared minus b squared, 16 minus 9. So I get c squared is 7. See how I'm just doing that real quick sequential order of doing it, setting it up like that? You'll be all right.
Oh, it hurts.
When we step on your foot, it'll go away.
I don't think that.
Okay. So if a squared is 16, what's your value of a? 4. So a is going to be plus or minus 4. B is going to be plus or minus 3. And c is going to equal plus or minus the square root of 7. What's going to happen a lot of times here is that your c value usually won't be a nice clean number. When we go to plot that, you'll have to do some sort of a decimal equivalent to set it up. Your a's and b's should usually wind up clean. If not, you might get like a 2 root 2. You can still kind of fudge the idea of where it's going to be placed. But you're going to be listing out ordered pairs anyway, so it's not that big of a deal. Again, everything's centered at the origin. If I know this is being stretched left and right, that means my vertices are going to be at the a values. All I do is walk it out. 1, 2, 3, 4. And I make my oval. Okay. So what I've done there is just done a real rough sketch of what it's going to look like. I know that my vertex is going to be at 4, 0, negative 4, 0. My co-vertex is at 0, 3, 0, negative 3. And then lastly, put in my focus. Will the focus be on the x-axis or the y-axis? It's going to be on the x-axis. So my focus is going to be at root 7, 0, and negative root 7, 0. What's the decimal equivalent of the square root of 7? Well, it's bigger than what and smaller than what? It's bigger than 2, but it's smaller than 9. Now, is 7 closer to 9 or is it closer to 4? It's closer to 9. So that means it's more than halfway there. So maybe, I don't know, 2.6? I don't know. Is that about right?
Yeah.
Okay. I'm just guessing, so it's going to be here and here. And that's all you got to do. And it's not going to change these same exact steps when we shift it with an h and a k. instead of being centered at the origin, will be centered at 2, -3. You still set up the exact same process. You still find your A's, your B's, you walk your distances back and forth. Yes,
You
sir?
have to make a parent.
No. There'll be no parent function for this one. What's going to be really nice is that you start at the center, and you'll see how it works itself out. It's very clean. It is very, very clean to graph these things when they're shifted. What becomes messy is when you have to work with the equation to figure out which one it is, because there's a little bit of rules here. Okay. Why don't you guys try one? Same idea. The whole idea is to graph, list these parts out. What do you got? Sorry. I guess I could have done this. You're okay now? Of course. Now that'll get the button. Do that one. Graph it, label all the important junk. Straightforward. Divide everything by 100. Yeah. We get x squared over 25, y squared over 4 equals 1. Is this one stretched left and right or stretched up and down?
Horizontal.
Left and right again, yeah, it's horizontal. So that means that my a squared is 25, b squared is 4, c squared is 25 minus 4, so it's 21. A is plus or minus 5, b is plus or minus 2, c is plus or minus square root of 21. Again, just straight labeling. Go to plot centered at the origin. Your vertex, your vertices are going to be on the x-axis, plus or minus -5. Co-vertices at plus and minus 2. There's your oval. Square root of 21, well that's bigger than the square root of 16, but it's smaller than the square root of 25, so 4.5-ish. And then again, all you have to do is label them out. Vertex, 5, 0, -5, 0. Don't write them as plus or minus 5, 0, because when we do the shifting, that doesn't work. Okay, I just want to get you guys in the habit of actually labeling out the 2 sets here. Okay? Is that okay? Let's just switch. B is bigger than A. Well, it's not going to be bigger than A because the when you have an ellipse, the A squared term is always represented by the larger of the two numbers. There's going to be different rules when we get to ellipses. When we get to an ellipse, then there'll be a little bit of a change there. Co-vertex, 0, 2, 0, -2, and then focus, root 21, 0, and root 21.
Wait, how many times was that?
Which one has the larger number underneath it? If it's larger underneath the x squared, it's left and right. If it's larger underneath the y squared, it's up and down. That's the only rule. Okay? Let me give you guys a couple of these to try. Yep. This is section 10, 10.4. Page 613.
Were you just doing all the others, like our homework from last night, so you remember?
That's fine. Yeah, that's a good idea. Put them on that homework from that, then we'll just get it all at once then.
I did mine on 2 pages.
No big deal. So go ahead and use those. There's 7 of them. There's 4 of them that you're graphing, like the 2 examples we just did. And then the last 3, they're giving you a vertex and a co-vertex. Write the equation. Didn't show you how to do that, but I'm sure you could probably figure it out.
On every other odd.
I know you ended at 75.
Yeah.
I didn't count it. So why should I start now?
Up there.